All right, in Chapter 1, Section 2, I found a few questions that were intriguing. Number 3, find the x and y intercepts of the graph of the equation. If there is none, then type in does not exist. So on an equation like this, if we're doing this algebraically to find the x-intercepts, we would set y equal to 0. And if we did that and set y equal to 0, we would find the place where we would get our x-intercept. If we were finding the y-intercept, we'd let x equal 0, and that would give us our y-intercept. Graphically, we can see this by, let's get back into Desmos so we can get the nice visual of what's going on. And so it was y equals negative absolute value of x plus 9. And if we look at this one, it's hanging out back here, right? So we see that it does have an x-intercept, and this one does cross the y-axis once. And so we have our points. Let's see. I believe that's all they're really asking on this question. It is possible at times for an absolute value function to have more than one x-intercept. It should only have one y-intercept, but it could have two x-intercepts. So when you're solving these, you just have to be careful on when you set your equation equal to 0, your y equal to 0, and how to solve this absolute value function. Another one that looked interesting was number 10. Oh, but I think I wanted to look at one of these too. Let's jump to number 10 and we might go back. 10 is talking about a circle, and it tells you the standard form of a circle, which is in your book, and its center is 2, -2, with the solution point -2, 1. So if we're looking at that, and we want to see it has a center at 2, -2, and a solution point at -2, 1, right? So we know that here's my center, this is the solution to it, so that means it lies on that circle that goes around here. So one thing we could do is find the distance using the stuff from section 1. If we know the distance between the center and the solution to the circle, that would be the radius, and then we would have that formula. The book gives us the formula of a circle as a x minus h squared plus y minus k squared equals r squared, where h and k represent your center and r is your radius. So that would be one way to do it, is to calculate this radius, and we know what our h and k is. So if I know what my h and k are, my h was 2, so this is my h, this is my k. And then I know I have my y value, so y minus, and it was a -2 is what that k value was. So we could just put plus 2 equals, I'm just going to type in r squared. Use one of the benefits of the slider. So I know as r is bigger than 1, 2, 3, 4, oh, was it 5? 5 looks pretty good. And we get that solution point of -2, 1. So our answer on this one should just be a 25 or a 5 squared. So we have the center at 2, -2, and a point on it of -2, 1. That means if we would have done the distance equation of this, we would have found that distance to be equal to 5. Another one that I saw was number 18. So use a graphing utility to graph the equation, use a standard setting. Pretty easy to do this in Desmos. Just graph this, x squared plus x minus 12. And then it talks about finding your x-intercepts and approximate your x-intercepts, y-intercepts. And so, again, one of the great benefits of using Desmos is it's real easy to get these answers. There's our x-intercepts, and there's my y-intercept. And we get a nice quick picture of the graph. Nice parabola shape with those intercepts. There is something with the homework. It was talking about symmetry. And so if we look at some of these, and they talk about using an algebraic test. Visually, we could determine if it's symmetric to the x-axis, y-axis, or the origin, which means the x and y-axis. But in the text, it also talks about graphically testing for symmetry and algebraically testing for symmetry. So if it is symmetric with respect to the x-axis, if you replace y with -y and you get the same equation, then that means it's symmetric to the x. To see if it's symmetric to the y, take your x and replace it with -x, and if you get the same thing, then it's symmetric to the y-axis. And it's symmetric to the origin when it does both of those things, and we get the same equation. So that might help with some of those questions.